All right, the last part of what we want to do here is to give you an actual concrete example, more concrete than the last one, example of how to implement this multivariable sort of change of variables idea. So what we're going to start with are two independent, identically distributed uniform random variables over the unit interval. Right, so x1 and x2 are both uniformly distributed over 0, 1. And just like we had in the last video, we're going to consider y1 to be their sum and y2 to be their difference. And just so you don't have to go back and double check, I rewrote the joint PDF for the new random variables y1 and y2 in terms of the old PDF here. All right, so all the work we did last time just says that it turns out to be 1/2 the old PDF with x1 and x2 rewritten appropriately in terms of y1 and y2. Okay, well, we can now come up with a much nicer formula, a much more definite formula for the PDF of y1 and y2. And the reason why is that we know exactly how x1 and x2 behave. They're both uniformly distributed over the unit interval, and, this is critical, they're independent. So that means that we know the joint PDF of x1 and x2 is going to factor into a product of the two individual PDFs. So independence of x1 and x2 tells us that f sub x1, x2 of any x1 and any x2, this is going to be exactly f sub x1 of x1, f sub x2 of x2. It very neatly factors. So what that tells us here is that our PDF in terms of y1 and y2, well, we just have to translate, right? We just have to say that x1 for us is going to have the very specific form y1 plus y2 over 2, and x2 is going to be y1 minus y2 over 2. And then the same factorization is still going to happen. And to just keep in mind what's going on here, we know exactly what f x1 and x2 are. I'll just write one of them here since they're identically distributed. The other one would be the same. Well, here it's going to be 1, since the interval has length 1, if 0 is less than x1 is less than 1, and 0 otherwise. So, if we translate appropriately, this tells us that f sub y1, y2 of y1, y2, well, this is going to be 1/2 fx1 of y1 plus y2 over 2. And just translating lowercase x1 into lowercase y1 plus lowercase y2 divided by 2. And we're going to multiply that by fx2 y1 minus y2 over 2. Now what we have to do is make the appropriate translations into piecewise functions. So what this is going to mean is that this is going to be 1/2 times the piecewise function. Well, the only valid outputs of fx1 are 1 or 0, which we see here. The conditions depend on the input, but the outputs are always just 1 or 0. And the same is true for x2. So that means that when we multiply them together, our only two options are still 1 and 0. Now, we get a 1 from this only when both fx1 and fx2 with these inputs are exactly equal to 1. Right? They have to simultaneously be equal to 1. And so that tells us the condition we want. This is if the input for both has to be between 0 and 1. The inputs we just need to translate are these. So if 0 is less than y1 plus y2 over 2 is less than 1, and 0 is less than y1 minus y2 over 2 is less than 1. And a very simple way of saying what happens if this doesn't occur is just to say that it's going to be 0 otherwise. Alright, so if this is violated in any way, then your function will just output 0. Alright, and you could rewrite these two conditions just a little bit, right? You could multiply through by 2, for instance, and you could have, the sum y1 plus y2 has to be less than 2, still bigger than 0, and here the difference would also have to be less than 2. Alright, so this PDF for y1 and y2 will be equal to 1, would be equal to 1/2, since we're multiplying by 1/2 here. It would be equal to 1/2 if simultaneously the sum y1 plus y2 and the difference y1 minus y2 are both between 0 and 2 on the right hand side. All right, so this is one example of how you can, when you've got very specific forms for your random variables, and in particular when they're independent, like they are here, let alone independent and identically distributed, then you can say really nice things about this new PDF for a function that somehow incorporates 2 functions of the old random variables and defines 2 new ones. So it's all very complicated, the lead up to it, but then the implementation actually turns out to be not the worst thing in the world.